So the method that we started in the last session, or the topic that we started mainly, solution of a system of equation. So that will continue again. So only one method that we completed in last session. So there are total 4 methods as we discussed. To solve the system of equation, we have Gauss elimination, Gauss Jordan, Gauss Jacobi, and Gauss Seidel. These 4 methods are there. Most important method is a Gauss Seidel method. This is the most important method. So maximum times the question comes on Gauss Seidel in the final examination. So that about the 4 methods we have. First 2 methods are known as a direct method. Direct method means they are without iteration, that we discussed. Now in Gauss elimination, we already seen to get a solution what we are doing. So suppose this system we are given. This one is the system of equation we are given. We write it in the matrix form AB. Then we reduce it in upper triangular form. We reduce in upper triangular form for by elementary row operation. So only row operations are allowed. By mistake also you should not use a column operation, column transformation. So here we made all entries below main diagonal 0, and that is known as upper triangular form. And once we have upper triangular form, we can get a solution by back substitution method. Last equation gives us the value for z. So like z equal to -2, y plus 5z equal to -6, which gives us a y equal to 4, and then x plus y plus z equal to 3 gives us x equal to 1. So that about the Gauss elimination method. So the first method, name of the method is Gauss elimination, and in which we get upper triangular form first, and then back substitution gives us a solution. Now, another important thing I want to tell you, throughout this topic we are going to solve those system of equation which have only a unique solution. Generally the system have a unique solution, infinite solution, or no solution, but only those numericals we have here which have a unique solution. And whatever the methods we are learning, actually these are programming method. All of you are already using scientific calculator. In scientific calculator, there is one mode where you can solve the system of equation, and behind the screen, actually, these algorithms are working there. So whatever the programming is made, that is made with the help of this algorithm. Okay. Uh, now, if we move to the second method here, Gauss-Jordan method, in Gauss-Jordan method, there is a little extra part that we have to do it. Instead of reducing the matrix, coefficient matrix A to the upper triangular form, we have to reduce it to the identity matrix. We have to reduce it to the identity matrix so that we get the answer directly. For example, suppose we reach up to here. Now, we can make these two entries 0 with the help of the diagonal position. I will tell you the most important thing in Gauss elimination and Gauss Jordan method. Whenever you have to make some zeros in the below the column or above that, always use a diagonal element to make the zeros so that other zeros will not disturb. For example, right now if we want to make these two zeros, we'll use diagonal entry as A33. We use A33 to make these two zeros. Okay, I will not use like say R2 minus 5R1, R2 minus 5R1, 5 minus this, you can make it as a 0, but at the same time these zeros will disturb. Okay, so because of that, use A33 to make this to 0. So the transformation, we have to use it here obviously by R1 minus R3. If you take R1 minus R3, 1 minus 1, 0, and R2 minus 5R3. And this gives us two zeros here. So you'll observe the matrix will be converted to, I'll write it here. So the last row will be unaffected, 0, 0, 1 minus 2. So this is the last row. Then we are applying, say, R2 minus 5R1. So this the 0, 1 will be as it is. R2 minus 5R1, so that should be the 0. Minus 6 plus 10, so it should be the 4. And lastly, R1 minus R3, so this 1, 1 will be as it is. This will not affect. And 1 minus 1, that's a 0. and lastly R1 minus 3 plus 2, it is becoming 5. And now in a last step we have to make this as also the 0. To make this 0, don't use C2 minus C1. Already I told, by mistake also you should not use a column transformation. So it should be a transformation here to make this 0. Yes, anyone? If you have to make this 0, what should be a transformation?
R1 minus R2.
R1 minus R2.
R1 minus R2. Very good. So to make this entry 0, use only the diagonal element. So A22 we should use. So R2 we should use R1 minus R2. And we get a matrix like 1 0 0 0 1 0 0 0 1, which is the identity matrix. But at the same time, this 5 R1 minus, sorry, R1 minus R2 is there. 5 minus 4. 5 minus 4, it is 1. Is that? Then 4 and minus 2. So that about the RHS constant. And now if you write it in the equation form, it is 1 into x plus 0 into y plus 0 into z equal to 1. So we get x equal to 1, y is equal to 4, and z equal to minus 2. So you get directly the answer: x is 1, y is 4, z is minus 2. And that is a Gauss-Jordan method. So whatever it is written on the screen, that is a Gauss-Jordan method. Okay, so that about this example. So there is a very small difference in Gauss elimination and Gauss Jordan. So we have in Gauss elimination, I will repeat. In Gauss elimination, this is the original matrix, augmented matrix AB. This is the matrix AB. So we have to just make all entries below diagonal zeros there. Okay, all these are zeros, and then back substitution gives you the answer. So this is the way that you will get a solution for Gauss elimination. And I will show you here it Gauss Jordan again. Here is a Gauss Jordan. Now different student can use a different transformation, but they can use only row transformation. But what is the ultimate aim? Your coefficient matrix should be the identity matrix. You have to convert this original matrix coefficient to the identity matrix by elementary row operation, and that gives you the values of x, y, and z directly. Okay, so values of x, y, z you will get as 1, 4, minus 2 there in a Gauss Jordan. So if you have any doubt in the first two method, yes, you can ask. Gauss elimination and Gauss Jordan.
Sir, let us note it down.
Yes, this PDF is already with you. That is one thing. Another thing, I know there is definitely one example you should solve on a paper, then only you'll get it. So for that, yes, there is assignment. So when you complete it, that time it is, you will come to know whether you are able to write whatever you understood. So we'll discuss that because on Monday you have to again do the assignment number 3, which is already uploaded on TMLMS, and that is on system of equation. So on Monday you have to complete it mainly. Instead of a Zoom session, you have to do that assignment. Here the missing things are the transformations not written. For example, you will observe these two zeros are there. These two zeros are there, means what is the transformation that should be done is like R2 minus 2R1 and R3 minus R1. So obviously these two zeros are appeared. Next, now we use this A22 position, which is 1 already, to make these two zeros. So we say R1 minus R2 and R3 minus 2R2. So this gives you these two zeros. Then first step we get these two zeros, next step these two zeros, and then last step we want these two zeros, and for that we use this element. First it is done like R3 upon minus 13, and this got as 1, and then use R1 plus 4 R3 and R2 minus 5 R3, like that. So these are the transformation which is done, and you get, so here little different transformations are there, but the answer will be unique. Your answer will not change when you change the method. Yes, Praneeth, already I told, in a Gauss elimination method, we make all elements below main diagonal 0. Okay, that is the upper triangular matrix. And in Gauss-Jordan method, we make below diagonal, above diagonal 0, and diagonal entries 1. That means we convert the coefficient matrix to the identity matrix. Is that clear? Okay, very good. So simple things you should keep in your mind, because understanding is most important thing. Gauss elimination method use elementary operation, convert the matrix in upper triangular form. That means below diagonal we have to make it as a 0, and the back substitution gives you a solution. While Gauss Jordan, you have to convert below diagonal, above diagonal zeros, diagonal entries should be 1, and you get the answer there. Yes, you should write what transformations you are using, Raj. Yes, definitely. Whatever I written on this right side, this transformation you write in the exam. Obviously, you should write whatever you are doing. Okay. Without that, you should not finish it. Okay. I hope there is no doubt in the first two method. So if there is no doubt, I'm moving here on the last two methods of solving the system of equation. So third method, now whatever the remaining two methods are, they are iterative method. As they are iterative method, that means there is iterative formula, just like a bisection method, Newton-Raphson method. We have iteration formula. We have some initial approximation. That way, this method works. Remaining two method. So we'll move to the Gauss-Jacobi method. So here I'm going to show you the Gauss-Jacobi method. So next question is here. Solve this equation by Gauss-Jacobi method. Okay, Gauss-Jacobi method. Now the things are missing in the questions are like we are not given initial approximation. Just like in Newton-Raphson method, if you have to find out the root of the equation, we take x0 equal to b, some number. We start with x0 equal to b, and we get the solution in Newton-Raphson. Similarly, here we require some initial solution to this system. So whenever in the exam initial solution is not given, always take that x0, y0 and z0s are 0. That means we are assuming 0, 0, 0 as our solution. So whenever solution is not given, assume it as a 0, 0, 0. That is the first thing. Okay. Next, stopping criteria, if it is not given, do at least 3 to 4 iteration. Whenever stopping criteria is not given, like this question stopping criteria is not given. So you can do the 4 iteration minimum there, 3 to 4 iterations. Okay. So that is another thing. Otherwise, if stopping criteria is given, similar to the algebraic methods, like correct up to 3 decimal places, correct up to 4 decimal places, then do that. Still it is repeating that decimals. And another thing, if it is given in the question, do the 5 iteration, then compulsory you have to do that 5 iteration, like that. So that about stopping criteria. Now come to the method. This is the question that we have to solve. Our aim is to solve this system of equation. Now what is the iteration formula? The iteration formula is taken, it is taken from the same given equations only. Like first equation, we can write it for x. I can write out 2x is equal to 5 minus y minus z. So can I write x equal to 5 minus y minus z upon 2? So the first equation, we can write it for x, and that is written here, the same, 5 minus y minus z upon 2. Second equation, this second equation, sorry, my mistake, this is the second equation here. This second equation is written it for y. You will observe y is equal to 15 minus 3x minus 2z upon 5, and that is written here only. And the third equation, this one, is written it for z. So what we have to do it, whatever the given system of equations are there, that you have to write it one by one for x, y and z. Only one important thing that you have to take care, that the system should be diagonally dominant. Now what is the meaning of diagonally dominant? When you write that
Sir,
system, whenever you write the system in matrix form, you'll observe the first instead of matrix, I will tell you, or if you write the equations
sir,
rear in the equation below each other, like 2x plus
sir,
y plus z equal to 5, that is the first equation. Second equation is a 3x plus 5y plus 2z equal to 15. And the last 2x plus y plus 4z equal to 8. So we have three equations for these three unknown, and you will observe in the first equation the coefficient of x is a larger than the coefficient of y and z. Okay, that should be there. If we take that equation for a formula of x, the coefficient of x should be larger there. Similarly, the second equation, the coefficient of y is larger than the coefficient of x and z in that equation only. And in third equation, the coefficient of z is larger than the coefficient of x and y. And that is known as a diagonally dominant. The purpose of diagonally dominance is whenever the system is a diagonally dominant, then the convergence is means it is a necessary condition. I'm not saying it is sufficient. It is only necessary condition for the convergence of a solution. Okay, so whenever the system is not diagonally dominant, we may not get a correct answer there. So that about the iteration method there.
Sir, there is a doubt, sir.
Yes,
Sir, you wrote x naught is equal to y naught is equal to z naught is equal to 0, sir.
correct.
So, yeah,
So, because these are iterative methods, we should assume some solution to this system. What is the question? Question is solve this system of equation. That means we have to find out x, y, z. Okay. So we are going to approximate that x, y, z by 0, and that is initial approximation. So whenever it is not given, we should take it as a 0 only. Okay. And that only I'm going to show it here. Now let me come to the solution mainly. The first thing you'll observe, this is okay. This is the equations we written from the given system. So we get x equal to 1 by 2, 5 minus y minus z, y equal to 1 by 5, and z equal to 1 by 4 times this one. So these equations are converted as iteration formula only. So we written left hand side, we written xn plus 1, yn plus 1, zn plus 1, and RHS is replaced by yn, xn, yn, zn. Okay, the first one written xn plus 1 equal to 1 by 2 into 5 minus yn minus zn, yn plus 1 equal to that, and that is the iteration formula for Gauss Jacobi method. So Gauss Jacobi method, the iteration formula you can get this way. Now we have iteration formula. So every time the iteration formula we get it from the given system of equation only. So this is the given system of equation which is rearranged for x, y and z first, and then iteration formula is written. What is initial approximation? We said x0 is a 0, y0 is a 0, z0 is a 0. So this is, if not given, you have to take it as 0, 0, 0 only. So suppose this we want x1, y1, z1. So what is the formula? x1 equal to 1 by 2 times 5 minus y0 minus z0. So this is 0, this is 0. So what is x1? x1 is 5 upon 2, 2.5. Then what is y1? y1 is, this is 0, this is 0, 15 upon 5, that is 3. z1, this is 0, this is 0. So z1 is 8 by 4, that is 2. So initially we have x0, y0, z0 here. With the help of that, we get here x1, y1, z1. We got x1, y1, z1. Now using this x1, y1, z1, we calculate this x2, y2, z2. So to get x2 here, x2 equal to 1 by 2 times 5 minus y1 minus z1. So here is y1 and z1. These values if you replace there, this is y1 and this is z1, you get x2 equal to 0. That way. And just you have to continue now. You have to continue this iteration till the stopping criteria given. In this case, stopping criteria is not given in this question. So just I completed 5 iteration. You can finish 4 also or 5 also.
sir, let us note down also simultaneously so that we can understand more, sir.
Okay, you can write it, no issue. If anyone have any doubt, yes, you can ask at the same time. This is the Jacobi method. One more method we have here. Last
Sir,
method,
one
Seidel.
doubt is there, sir.
Pardon?
One doubt is there, sir.
Yes.
How y0 is 0? How, sir?
How means it is
Okay,
this is
it
the
is
iterative
okay.
method.
Okay, sir.
We are going for approximations only. We are finding approximate solution by initial guess, and the guess we are taking it as a 0 only. You can take 1, 1, 1 also, but for uniform calculation, it is generally assume that initially whenever it's not given, you should take it as a 0, 0, 0 there. That's one only.
Sir, why did we stop at the fifth iteration?
So already I said about that. In a question, nothing is given. Stopping criteria is not given. So you can do 3 to 4 iteration minimum there in the exam. Right now, Jacobi method is not a better method. Because of that, you will observe the route is not, we are not getting a better route actually by a Jacobi method because it is not a faster convergent method. This same example we are going to solve now by Seidal method, and you will observe we reach to the correct answer there. Okay. So in this case, stopping criteria is not given. So our whenever it is not given, it is up to us. But minimum 3 to 4 iteration you should do it, so that you get means examiner will come to know that yes, you are able to do the iterations. That's only he want to check that time. But generally in the examination, stopping criteria is given. Okay, if not, then if stopping criteria is not given, generally you have to do the iteration till you get the accurate answer there. So that type of the questions are coming in exam. I will show you which are the questions from your final question paper, that I will show you after this only. In this case, actually this is not a good method. Because of that, route is not correct, whatever the final route we get. So at the end we are observing here, like x is near about 2, x is near about 2, y is near about 3, y is near about 3, and z is near about again 2. Okay, roughly we are saying this is approximately I'm saying. Okay, actually there is too much difference, but roughly I said. But if you take fourth iteration, what is x? X is near about 0, y is again near about 1, and z is near about 0. So you observe 0 1 0 and 2 3 1. So there is big difference in approximation in fourth and fifth. So this is like not convergent right now. This method is not converging. There is a more theory behind this. Actually there are necessary and sufficient conditions for convergent. In this case, only sufficient condition is satisfied, that is a diagonally dominant, but there is some necessary condition regarding the norm of that. So that is not part of our syllabus, so we are not going in that. So just you will observe this case. You even though you do 100 iteration, this by this method, you will not get the correct answer for this question only. Okay, it's not like all question. Some other methods, sorry, some other questions, it will converge and you will get the correct answer also. Can we move to the last method then?
Sir, wait for 2 minutes, sir, please. I'm writing.
Complete it. So which are the important things for Gauss Jacobi method? First thing, diagonally dominant. System should be diagonally dominant. Second thing, write iteration formulas. And then to calculate x1, y1, z1, use x0, y0, z0. Okay, obviously. To calculate x2, y2, z2, we use x1, y1, z1 there, like that. Just obviously, in this case, this set of x2, y2, z2 depends on these values we use here. Now these values, this x2, y2, z2 we used here to get x3, y3, z3. Now these x3, y3, z3s are used here to get x4, y4, z4, and these values are used here to get x5, y4. So that way it is continued. So it is just set of the values we use to get the first iteration, the first iteration values we use to get the second iteration, and so on. Okay, come to the last method here, which is a Gauss Seidel method. Now there is a very small difference in Jacobi and Seidel method, which results to a very good method and a best method which converges faster than the Jacobi method known as a Gauss Seidel method. And what is a key point that you should remember for Gauss Seidel? And that point is use latest available values. Use latest available values for a Gauss Seidel method. That means if the same question is there, if this same question is there for Gauss Seidel, we have this same iteration formula. Sorry, we have this is it. This iteration formula is of Jacobi, where when we calculate x1, we use y0 and z0. We use y0 and z0 to calculate x1, and we get x1 as 2.5. So same x1 you will get for Seidel method. Okay, for Seidel method you will get the same x1, that is 2.5. But when you calculate y1 now, when you calculate y1, it become 1 by 5 into 15 minus 3 times xn. Now here for x we have x0 is also available, or x1 is already available. Which is the latest value available for x? That is x1. So we use here x1 instead of xn. We say that as xn plus 1. That means when you calculate yn plus 1, 15 minus 3x1 minus 2z0 only. Why z0? Because z1 is not available. So here is zn only. So in this case, the formula will become 15 minus 3 into 3, not 0. It is instead of 0, this become 2.5. So to take 2.5 there, and you get here as a y1, some value for y1, different value. Okay. Now when you calculate z1, you will available x1 and y1 are available instead of x0 and y0. This x1 and y1 is available. So here is a change in formula, xn plus 1 and yn plus 1. So that is the formula. This is the formula for a Seidel method. So Seidel method only use the latest available values. Let I show you the same question in Seidel form. So I'll come to here. So here, this is the question that we have. We have to do this, solve the system. So values of x, y, z written first. Now formulas, when you write a formula for xn plus 1, yn and zn should be there. But for yn plus 1, we use this xn plus 1 here. Instead of xn, we are not writing xn. We use xn plus 1 because xn plus 1 is already calculated, and zn as it is. And for zn plus 1, we use both xn plus 1 and yn plus 1 because that is already calculated there. And you will observe the same question if you do by Seidel method, this x1 will be the same. That will be the same. There is no change. But y1 and z1 will be different. These are different values because different formula is there. Because we are using the latest available values. And once we get these different values, you get x2, y2, z2. Everything is different. Every value will be the different every time there. And I will show you first that important part here. When you come to the 5 iteration again, you will observe every time you are moving to the similar values there. So here x1 is this one, 1.43, and here this x4 is this one, and here x4 is there. So roughly your x is converging to the 1. Y is like this, and here is value of y is that one. So y is converging to the 2. And lastly, here is z, and this is a z. So z is again converging to the 1. So approximately, the approximate value of x is 1, approximate value of y is 2, approximate value of z is 1. So 1 to 1 is a solution for this system of equation by Gauss Seidel method. And you will observe, you can cross check. Let me cross check this solution. So to cross check that solution, we'll move to the system here. So replace x by 1, replace x by 1 roughly, y by 2 and z by 1. So 2 into 1 is 2, plus 2 plus 1. So 2 plus 2 plus 1, that is 5. It's satisfied. So this is 3 plus 10 plus 2, 15. That is satisfied. Then 2 plus 2 plus 4, 8. That is satisfied. So you will observe Gauss-Seidel gives us a correct answer because it is a faster convergent method. It is using latest available value. So these are the things are there in the Gauss-Seidel method. So if you have to start this question by a Seidel method, how to start? So this is the example you are given. First rewrite the equation like this: 2x plus y plus z equal to 5. Next equation 3x plus 5y plus 2z equal to 15. Last equation 2x plus y plus 4z equal to 8. First check whether it is a diagonally dominant. Means 2 is a greater than the coefficient of y and z. Yes, the coefficient of x is larger than y and z. In second equation, coefficient of y is larger than x and z, and in third equation, coefficient of z is greater than x and y. So this is a diagonally dominant. So first condition satisfied. Now write a formula for x, y, z like a Jacobi method. So this is just like a Jacobi method. So we are writing from first equation, we write for x equal to 5 minus y minus z upon 2. X equal to 5 minus y minus z upon 2. Y is equal to 15 minus 3x minus 2z upon 5. That is y. And lastly, z equal to 8 minus 2x minus y upon 4. So that about the formula for z. Once we get that, we write a iteration formula. This is the main thing. This is the very important part for the methods. If we have a Jacobi method, if we have the Jacobi method, just we write these xyz as xn plus 1, yn plus 1, zn plus 1, and RHS. Every xyz is replaced by xn, yn, and zn for Jacobi method. Okay, Jacobi method is that way. But Seidel method, to get xn plus 1, we use yn and zn. For yn plus 1, if you write yn plus 1 equal to 1 by 5 into 15 minus 3 times x. Now for this x, we are not writing xn because before yn plus 1, x is already appeared. That is xn plus 1, we write it. Okay, this latest value will use it there. Both these latest values we use that there. So that's only the formula is only different. And then once you have the formula, you have to do a calculations only. Yes, any doubt?
No, sir.
Very good. I will so z and value in a second equation. Yes, because when you calculate yn plus 1, which value is only available? Value of xn plus 1 is only available. Zn plus 1 is not still calculated. Na? Zn plus 1 is below yn. Na? Are you getting, Pranit? Where is Zn plus 1? Zn plus 1 is below that. So when you calculate Zn plus 1, yes, both are above it, means both values are available. You can use that. You can use that. That is the simple logic there. So in Seidel method, just yes, Zn is 0. Zn is 0 because initially x0, y0, z0s are 0. Okay, we started with 0, 0, 0 only. Okay, that way. So I will show you one more here. Just 1 minute. Your assignment 3, which is already uploaded on TMI-LMS now. This assignment 3, you have to do it on Monday. You'll observe all these questions are from your question paper. None of the question I have taken it my own. All these 5 questions are from your previous question paper. Okay, previous question, except Gauss elimination. Sorry, except Gauss elimination. This example is in your textbook. The question number 1 is in your textbook, but this is not never asked till in your final examination. But you'll observe every time you have some answer there for a particular answer, that type of the questions are coming in exam mainly. Here, first question is on Gauss elimination method. Gauss elimination means you have to reduce in upper triangular form and then back substitution. That about first question. Question number 2 is on Gauss-Jordan. So this time you have to reduce the matrix to the identity matrix, and you get directly that answers there. Question number 3 is on Jacobi method. In Jacobi method, we already observed we have to, as again in this question, stopping criteria is not given. In this question, initial approximation not given, so we should start with 0 0 0. Okay, 0 0 0 is a better choice, and you start there always. And you use a Jacobi iteration formula to get that. And last two examples on Seidal method. Is question number 3 is a diagonally dominant? Anyone? Question 3, is it a diagonally dominant?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Yes, very
Yes,
good.
sir.
Because here x coefficient is larger, y is larger, z is larger, so it is already diagonally dominant. And you can use as it is these formulas of x, y, z. What about question 5? Is a question
No,
5?
sir.
No. So everything is given in a question actually. If necessary, rearrange equation for achieve a convergence. Means you have to convert it diagonally dominant. So what should be the first equation? Tell me. What should be the first equation in question number 5?
6x minus y
6x
minus.
minus y minus z equals to 40.
6x plus 9y plus z equal to 40. That should be the first, which gives you the formula for x as 40 minus 9y minus z upon 6. Is that about the formula
Sir,
for? Yes.
sir, the first
The
equation
second
must be
equation
6x minus y minus z
Minus,
equals to 40.
Okay, my mistake. Very good. You are correct. So because here the coefficient of x is larger as compared to y and z, and here the coefficient of y is larger than x and z. So this should be for x, and you get x equal to 40 plus y plus z upon 6. Correct. And this for the y then, is it? And you get y equal to 40 minus 6x minus z upon 9. And then we got last here that first equation, which you get it as a z equal to 50 minus 3x minus y upon 12. And this becomes the formula for Gauss Seidel later on. So you have to write it in the form of xn plus 1, yn plus 1 and zn plus 1. Okay, so this way you should start, and only 2 iterations you have to do it. 2 iterations you have to do it. So answer is not given. I will check it with your submission only. Okay, so that about your assignment on Monday. So Monday you should do this calculation, do this assignment, and you should submit it on portal TMLMS. So Monday you don't have a Zoom session again. Okay. If you have the doubts, yes, we'll discuss about